Welcome to today's lesson. In this first tutorial, we will be able to solve polynomial inequalities. We are in section 3.5 in our textbook, and we're going to be looking at a very interesting technique to help us solve these inequalities. What I'd like to do is go through each of the steps alongside this first example. So our first step is set equal to 0. I don't really mean equal to, I mean less than, greater than, less than or equal to, greater than or equal to. These are not equations, these are inequalities. So whichever one of the four inequality symbols we have, put a 0 on the other side of it. So clearly in this first example, I do not see a 0. I like my quadratic term to stay positive, so I'm going to bring everything over to it. If I subtract 4x, I'll have a negative 4x. Subtract 12, there's a negative 12. Subtraction does not change my inequality symbol. Only multiplying or dividing by a negative number would change the inequality symbol. So there's my 0. That's my first step. My second step, find all zeros and excluded values. Zeros are like roots or x-intercepts, and they come from the numerator. So any value that would make a numerator equal to 0 is called your root, or is called your 0. Excluded values come from the denominator. Those are like our vertical asymptotes when we're graphing our rational functions. So I go over here and I look at this. Well, first of all, I don't see any denominators, so there's not going to be any excluded values. I will only have zeros, and I will have 2 of them. It's quadratic, so most likely it will factor. So let's see what happens here. X times x. There are a few options for multiplying to give 12. 1 times 12, 2 times 6, 3 times 4, but the numbers that are going to help me give a 4 are the 2 and the 6. So I'm going to try that. It's also a negative 12, which means that one of them has to be negative and the other has to be positive. If I need a negative 4, then the negative should go with the 6 and the positive with the 2, and that checks. So now I know that my zeros will be a negative 2 from this factor and a positive 6 from this factor. I do not have any excluded values, again, because I do not have any denominators. So these are the 2 numbers that will make this equal to 0, and it's important to find those. Step 3, use these values that we just found to create a number line. So I'm going to just draw a number line. It's really just a picture to help us find all of the answers to this inequality. I'm going to put the negative 2 and the 6 on my number line. Negative 2, of course, would be on the left side. 6 would be on the right side. I really don't want you to go crazy and put all the other numbers on the number line. Really, we just need these 2 numbers. I'm going to take a quick look at my inequality symbol, and since I know that this is strictly less than, that I'm not actually including the zeros like these symbols. These symbols would be including the zeros. Since this is strictly less than, I like to put an open circle right here and an open circle right here, because I'm not actually interested in when we're equal to 0. I just want to know when we're going to be less than 0. Okay, so step 4, we're going to be testing a value in each interval to determine if the function is either positive or negative. I hope you understand that there are only 2 numbers in the world that would make this equal to 0. So that must mean that every other number other than negative 2 and 6, every other number has to make either a positive output or a negative output. So we've created 3 intervals. This first interval from negative infinity to negative 2, this middle interval from negative 2 to positive 6, and this last interval from positive 6 to positive infinity. We need to test a number in each one of these intervals to see if we get a positive or if we get a negative. So you can pick any number in this first interval. I'm going to choose negative 10. If I plug in negative 10 for x into my factored form, and I like to plug into the factored form because I think it's easier, negative 10 plus 2 creates negative 8. I don't really care that it's a negative 8. What I care about is that it's a negative number. When I plug my negative 10 into the other factor, I get negative 10 minus 6, which of course is negative 16. But again, it doesn't matter what the number is, it matters that it's a negative number. Now I know that I have a negative times a negative, which we all know is positive. So any number, if you pick negative 10, or if you pick negative 3, or if you pick negative 2.1, any number in this interval is going to create a positive output. So we've tested that interval. We have 2 more to test. Let's test this middle interval. You can pick any number in between negative 2 and 6. I'm going to choose to pick 0, since 0 is relatively simple to plug into. So plug into the function. So 0 plus 2 creates a positive. 0 minus 6 creates a negative, and a positive times a negative is a negative. I like to put my positives in a circle above the number line and a negative in a circle below the number line. And I have one more interval to test. Anything bigger than 6. I can pick anything bigger than 6. I'm going to pick 100. If I pick 100, 100 plus 2 is a positive. 100 minus 6 is still positive. And a positive times a positive is a positive. So I've tested my intervals and I've figured out which intervals create positive outputs and which interval created a negative output. Our final step is to answer the question. Now we definitely need to look at what inequality symbol we're talking about. We're talking about less than 0, and that of course are negative numbers. So we're talking about this negative interval right here. That will answer our question. All the numbers between negative 2 and 6 will solve this original inequality. And that's the technique we use to solve. Pretty cool. Let's follow the same steps and look at example number 2. Step 1, again, set it equal, quote unquote, equal to 0. I don't see a 0, so I'm going to choose to subtract the 8x to this. This time I have a quartic term, x to the 4th minus 8x, and that will be greater than or equal to 0. There's my 0. It's important to have that 0 for our number line. Now I need to find all of my zeros and all of my excluded values. Well, again, I don't have any excluded values because I don't have any denominators. So I'm just looking for the zeros, and there should be 4 of them since that's the degree. Let's see if we can find them. This is a binomial, so there's something special going on here, and I instantly see that there's a GCF. So let me pull out that GCF, and I'm left with x cubed minus 8. Okay, so I know one of my factors, here it is. But there's still 3 other factors and 3 other zeros that I could be finding. This is a difference of 2 perfect cubes. And this is another pattern that you should be familiar with from Algebra 2. So let's remind ourselves how to factor a difference of 2 perfect cubes. Firstly, I'm going to keep that GCF out there. Of course, that doesn't go away. The difference of 2 perfect cubes will factor into a binomial times a trinomial. I like to put the binomial directly underneath the difference of 2 perfect cubes that I'm factoring because that already is a binomial. So that's the binomial. How we get the binomial, we take the cube root of the first piece, which would just be x, and the cube root of the last piece, which would be 2, and we keep the same sign. The trinomial depends on what you have for the binomial. The first part of the trinomial will come from taking the first part of the binomial and squaring. So this becomes an x squared. The last part of the binomial, of the trinomial will come from taking the last part of the binomial and squaring that. 2 squared, of course, is 4, and this will always be a positive. The middle part of the trinomial comes from multiplying these 2 items together. X times 2 is 2x, but changing the sign from the negative to the positive. Remind yourselves how to factor a difference of 2 cubes. A sum of 2 cubes factors the same exact way, except for a sum, of course, we'd have a plus sign here. So therefore, this would be a plus sign. Then this would be a minus sign because this will always be the opposite of this. This one is always a plus sign regardless. So go back and review that and maybe take some notes right now about when you're squaring and when you're multiplying. And there we go. So this is greater than or equal to 0. I don't want to lose my equation part, right? Greater than or equal to 0. So now we've got, now it looks like we still have 2 more factors in here because we still have the x squared. You can try all day long trying to factor this. This will not factor. There's actually 2 imaginary numbers that would come from this trinomial. You can use the quadratic formula to find them, but I'm really not interested in imaginary numbers. I'm interested in real zeros. So let's find those. The first one, of course, is 0, and we knew that as soon as I pulled out my GCF. My second 0 is 2, because that's the number that would make the second factor equal to 0. Only imaginaries would make this equal to 0, so I'm done finding my zeros. There are no excluded values here either. You can go ahead and list that there's nothing there, or you can just not do that part. Now I go to my number line. I'm going to put my 0 and my 2 on my number line, in the correct order, of course. I'm going to take a quick look at my symbol, and it does say that I get to include my zeros this time because the equal to. So I'm going to put a closed dot on here. This will remind me that I can include those values. Now I do my tests. I pick any number in this first interval. I'm going to pick negative 10 again. I plug in negative 10. Now I could plug it into this factored form, or I could plug it into this factored form, whichever one is easier. I think that this one might be a little bit easier because I really don't want to plug in a couple times here. Doesn't matter to me. You could plug into this blue part right here. I'm going to plug in negative 10. Negative 10 plugged in right here, of course, is negative. A negative 10 cubed is very much negative. Subtracting 8 is even more negative. So I'm going to get a negative times a negative, which is a positive again. There aren't that many numbers. Okay, there are infinite numbers in between 0 and 2, but there aren't many integers. I'm just going to choose to pick a 1. I'll choose 1. If I plug a 1 right in here, obviously 1 is positive. If I plug a 1 into here, I get 1 cubed minus 8. Well, that would be 1 minus 8, which is negative. So that must be my negative interval. And now I need to plug something in here. Maybe we pick something that's obscenely large, like 1,000. Sometimes when you pick a very big number, it makes it easier to do. So if I pick 1,000 and I plug 1,000 in here, that is going to be a positive. 1,000 cubed is huge. Take away 8. Subtracting 8 is not going to do that much. It's still going to be very much positive. Positive times positive is positive. So I figured out my intervals. It looks like it's a plus minus plus again. And now I need to locate, there it is. I need to figure out what I'm talking about. This time I'm talking about greater than or equal to 0. Well, greater than is positive, and obviously equal to 0 is equal. So I'm looking for the positive ones this time. That's this interval here and this interval here. So I will be describing this interval as negative infinity to 0. This time I get to include the 0. That's why this closed dot is so helpful to me. And since there's another interval, I'm going to union that with the other interval, which is 2. Again, I get to include the 2, so I use my bracket all the way to infinity there. And that is my final answer for all the values that would solve the original inequality. Thanks for watching this tutorial on polynomial functions, and in the next one we'll talk about rational functions. See ya.